Hello, everyone. Thanks for joining this session. So today, Miss Iram is going to explain about the deep learning process and applications. Thanks, Miss Iram, for being here with us. So now the floor is yours. Thank you.
Thank you, Dr. Tanzila. So, welcome everyone. Today we are going, as usual, a little bit about on deep learning. So, I have again few files on you can say Light GBM, and the other one is on Cat Boost. So, before going into detail, I just want to explain what are these algorithm, where these algorithm were actually started, and how we can use that. So as we discussed in during last week, there are only three lines of code to apply any model. So just calling the library, fitting that your data to that, and then checking uh, your result on that. But what does that algorithm mean, and how we use that? For that, I actually prepared uh, its slides, but those were not detailed, and I came across such really amazing you can say resource. I'll share that with you. You can practice it by like at your own time, and I'll explain you over here what does mean by that also, right? So when we say cat boost, so it is actually algorithm based on uh, the tree normal R tree algorithm. So we have gone into detail what does mean by uh, tree algorithm, how we make categories. So it is just an extended version of uh, you can say tree algorithm, right? What is it actually? So it is recently open source machine learning algorithm from Yandex, and it can easily integrate with deep learning framework like Google's TensorFlow and Apple's Core ML. So actually, the most like it's quite interesting algorithm, or its performance is really good. Like Google TensorFlow and Apple Core ML is using this. Why they are using? Because it works with diverse data type. Like you know if we have a data different data type like integer, audio, videos, and different kind of what we can say data set inside our data, so it can work very accurately on different data types in our data set, right? So it's powerful in two ways. First, it's real state of art result without extensive data training typically required by other machine learning method. Or if you are you have gone through deep learning, you must already aware how deep learning used to be extensive in term of power and data computational as well. Uh, since being in category of deep learning, it does not require extensive data training, so that's why it considered as a good algorithm. Then the other advantage is it provides a powerful out of box sports. Normally whenever we use an algorithm, we have has to refine inside the boundary, like these are our starting limits, our requirement to start or to apply the algorithm, and then few ending bound are also attached. But with cat boost, it supports the more descriptive data format that accompany many business problems. Like it's not for any kind of specific problem of categories. And cat mean categories and boost mean boosting. So it is normally applied on categorical data. So I'm not you can read over here what does mean by gradient boosting and so on. For example, uh, uh, we have let's read this one. So it can also return a very good result very relatively with less data, unlike uh, data learning models that need to learn from massive amount of data. Like we are always required, hundreds and hundreds of records to understand or to train the machine. But in contrast, cat boost can work on small data set also. And advantages of the libraries is, first one is its performance. So cat boost provides state of art result and it's competitive with any other machine learning algorithm on its performance base. Because it why its performance is high, because it is not, you can say, uh, ex, uh, power extensive, or you don't have to required what we can say, more resources in terms of memory, in term of computation or hardware requirement. And the other thing is that it it works on level by level of the trees, right? So it's it is considered as a good model. And as comparatively during the previous competitions, it has observed, like in WIDS 2020 and 2021, there were cat boost were applied even by the winners of uh, the competitions as well. Handling category features automatically. So it handles most of the features automatically. As the purpose of tree algorithm is to divide our feature in different categories and then work on that. So it's again based on tree algorithm, so that's why most of the time it automatically handle relevant categories. We can use cat boost without any explicit pre-processing, as we do in machine learning algorithm. That is the feature of deep learning, to convert categories in numbers. For example, if we have a category in different formats, so it automatically convert that into number. For example, picking uh, certain features from image, from audio or video. Cat boost converts categorical values into number using various statistics on combination of categorical features and combinations of categorical and numerical features as well. So here is a link. I have read that. You can also go over here. I have already shared the link, so you will have that. It's robust as well. So why or how is it robust? It reduces the need for extensive hyperparameter. So hyperparameter tuning, we'll discuss a little bit about hyperparameter tuning as well. It is also, you can say, computational extensive activity as well, because we pick up one value and iteratively check certain feature. And if we have n by n time, we might have re- we might have to occupy resources to perform hyperparameter tuning as well. So it's robust because it reduces hyperparameter tuning, and lower chances of overfitting is also considered. There are less chances of overfitting in cat boost algorithm. And uh, overfitting is actually when you have, you know what does mean by overfitting and underfitting as well. So if you don't, I can explain you this as well, which also leads more generalized model. Although cat boost has multiple parameters to tune, and it contain parameters like number of tree, learning rate, regularization, tree depth, fore size, bagging, temperature, and others. So in the algorithm itself, if you remember, I have shown you over here. So we have a model with certain features like verbose, devices, task type, learning rate, objective, loss function, and these are actually features of uh, our algorithm. So over here we are saying uh, the model have multiple parameters to tune, and it contains the parameter like number of trees, how many trees we are going to, like how many branches we want to build under this algorithm. Branches, we can say like those are levels of the tree. Learning rate and regularization. If you have done deep learning, you must know what does mean by learning rate, like how the model is uh, what is the curve of learning. So it's also being between 0 to 1. So and whether it is linear learning, or you can say it is gradually increasing or decreasing, something like that. And then regularization function, depth of the tree. So first of all we are saying how many trees will be there, and then how many sub branches of the tree would be, fore size would be, bagging temperature, and so on. So it have many features in the model itself. So we don't need to go to the hyperparameter tuning and then redo everything again, because the while building the model, these things were taken care during the application of model. And is the last one is easy to use. So you can use it, it's very user friendly, and as I have just shared with you, you just need to write 3 lines of code and you can do that. And we have multiple boosting libraries like XGBoost, H2O, Light, GBM, or we call it LGBM, and all of these perform well on variety of problems. CatBoost developers have compared the performance with these actually algorithm on the standard ML dataset, and it was found it is working better as compared to the other one. And how we do that, we need to install this pip install cat boost. And then if you want to install the package through devtool, you can. That is for all, this is for Python, for if you are using our Python programming language. So this is not for us, we are going to use this one. And then we have a complete shell, you can say a problem. Big mart sale is actually a, a data set, big data set, on which it was implemented. I would recommend go through that code and apply it by yourself, and you will learn how is it working on any kind of data set, or you can use your own data set and apply these algorithm. So we have this learning rate. So initially the learning rate was this one, and gradually it's going down, right? So that's it for like that just an introduction. So I had that in the slide what does mean by that, but I found this that article very interesting, so that's why I have shared that with you. Then there is another article, 5 cute feature, and that is also, these are also very amazing. So you can go through that also, like how these algorithms are what are the feature of cat boost algorithm. Like it has a built-in parameter to introduce to reduce overfitting, as we have discussed, like hyperparameter tuning. then has a built-in parameter to generate learning curve. We don't need to generate a learning curve separately, right? And what is learning curve? Learning curve is extremely important to monitor the learning process, like how, for example, if we have 50 iterations, so in 50 iterations, how model is working and what is its learning rate, how model is what we can say, moving forward with certain parameters. So you can have this one as well for reading. So any question up till now? If no, then I will just go through this uh, file that is again taken from the Kaggle dataset, WiDS Datathon 2022 cat boost. So we imported relevant libraries, for example, NP and pandas. For computation, we use NP, NumPy, and Panda is used for data frames, and we call cat boost. I have already installed, so I didn't need to install it, like pip install cat boost. From cat boost import cat boost regressor, and then from Skylern import model selection, right? So these are the four libraries we need to import them initially, then reading the data set, train data set, then we have a test data set, and then we need to know what is submission file. We can go through on it later. EDA is exploratory data analysis. We have already done that. Info mean, we want to know what does mean by, like, uh, overall description of data. What is name of the column? How many null values are there? What is data type in the column? We have gone through in detail in last session. Then we have pseudo labeling, modeling. So from modeling onward, we are going to apply cat boost. So we will have iteration 35k. So it's up to you how many iteration you want to add, right? So you can maybe have 500 iterations, 200 iterations, 300, so depending upon how many values you have, so that you can apply those iterations. Learning rate is 0.0225. Depth of the tree is 8. Task is going to be performed on GPU, not CPU. We don't have any device like NVIDIA or any GPU, which we are using it on normal GPU. We don't have NVIDIA device. Verbuses are the number of lines we want to display. So we have defined all our features of cat boost in a function, and then we will call that function later on. So you already know how does the function work. For example, if I always add a simple function. For example, I want to add two numbers, some x and y, and then I don't need to follow the process. I'll just simply call this sum function whenever I need to add two number, right? So I'm writing over here return x plus y. So that is a simplest. So it's a function definition, like how functions are used. Similar way, we have created a function and added parameters over here, and uh, after that we can call this function whenever we want to apply this function on the data set. We are not using k-fold for moment. Uh, let's not discuss now, or we can do that. K fold is actually a hyperparameter, so I don't want to. So I'll come to this point later on. So it is actually printing the result of whatever we have applied over here, right? So just to conclude that the cat for cat boost, we just need to define certain parameters, and then we just have to call this function, and it will work fine. We might not be, uh, uh, required to put or assign every single value of the parameter itself, right? Okay, any question up till now? If there is no question, then I'll move forward with other uh, that is LGBM, other algorithm. LGBM is taken from this blog again. That is an amazing, what we can say, blog to read. Again, it's a tree based algorithm, but it is used on a level basis. So it is a fact that decision tree based machine learning algorithm dominate Kaggle competitions. More than half of the winning solution have adapted XGBoost or LGBM, right? So recently, Microsoft announced its gradient boosting framework, that is LGBM, that is actually a variation of XG boost, and it steals a spotlight in gradient boosting machine, and Kegler start using LGBM more than XGBS because of its lightweight algorithm. Even though XGBoost might have higher accuracy, LGBM runs previously 10 times and currently 6 times faster than XGBoost. So whenever we create a machine learning algorithm, so we don't compare the accuracy only, we check the resources and computational power as well. So if a model is working accurate but it takes hour and hour to be executed, so we might not prefer it. So it should be a win-win situation, like an algorithm that could provide a reasonable accuracy. Along with that, it should uh, not use much computational and hardware resources as well. So there should be a balance. So LGBM stands for lightweight gradient boosting machines, and gradient boosting machine builds sequence of trees. Each tree will build based on the previous tree error. Final prediction will be made by the sum of those trees, as we discussed in sample algorithm, if you remember previously. And how it works, we normally import LGBM as LGB or whatever. And how it works, so we have a level wise tree growth. For example, we have a highest level and then two subcategories. And if I make this like the green are top level roots, and blue are actually nodes. So if I want to make this blue as a node, then sorry, as root, I need further you can say nodes. So this is actually basic tree, and that is extended one. and we can expand it maximum to 5. So I have opened this one, that is really amazing explanation. So have let's watch it and then we will move forward.
Hello. Today we are going to mention gradient boosting machines, or shortly GBM. Some sources mention this method as gradient boosting decision trees or gradient boosting regression trees. GBM is a procedure to improve the accuracy of decision trees. Suppose that you have a data set consisting of m different instances, and X refers to features, whereas Y refers to targets here. And we are going to build a decision tree, and we feed the base data set to the decision tree, and decision tree gives us some predictions. Here H refers to predictions of the decision tree. Now we are going to build another decision tree, but instead of feeding the base data set, we will feed actual values minus predictions as targets. In other words, we just feed errors, and the second decision tree gives some predictions too. Here, H2 refers to predictions for the second run, and similarly, we will feed errors again as targets in the following runs, results of the decision tree. And its mean squared error, which is actual minus prediction squared value over 2, and partial derivative of the loss function with respect to the prediction will be actual minus prediction times minus 1. And gradient descent algorithm states to update something with its negative gradient.
So so that was actually explanation of uh, uh, gradient boosting, so how it actually works. So in LGBM, at every level error of the tree is collected, like what is error over here, and at the end every error is sum up, if you remember ensemble algorithm, right? So and again that is very amazing example. If you pick that up, that is just the one we discussed the other day, like outlook look is sunny, overcast and rain, and then against sunny we have two trees with different temperature, humidity, wind and decision. And then for overcast we have one tree. For rain again we have two tree against the similar, like we have values against temperature, humidity, wind and decision. And that is really, you can say, amazing example to implement LGBM, right? I don't want to go into detail. If you want, I can uh, go through, or you can do it by yourself, or get back to me if you are not able to understand that. The code is pretty straightforward, right? So once we are creating this over here. Once we have done pre-processing, what we are doing, we are applying that, right? LGBM train on train dataset and test dataset with certain features and categories. And similar to the cat boost algorithm, we have certain feature over here as well, like which type of boosting we want, LGBM or gradient boost, what is the objective function, how many number of the classes are there, what is the metric, like how we are going to calculate that what are verbose, etc., right? And then we apply that with those parameters. So params mean these all algorithms. And if we want prediction, for prediction we have similar values. Anything on LGBM? So I'm assuming either you are not getting it at all, or you are getting everything. So we have LGBM stand for lightweight gradient boosting. We already gone through that. Gradient boosting machine builds sequential decision tree. Each tree will build based on previous tree's error. Finally, production will be made by the sum of errors collected at each tree. When we talk about gradient boosting, we may think about XGBoost. XGBoost applies level wise growth, whereas LGBM applies leaf wise tree growth. So if you see, we have already discussed, like we try to convert leaf to root and then extend the tree. So you can see over here. So we have these two leaves, and we are converting them into uh, root and then creating other uh, what we can say
So,
forms over
Ira,
here.
I
Yes,
have a
please.
question there. So is the difference then the previous tree's leaves, the errors from the leaves will be considered in the next tree's root and it continues? I'm trying to understand the difference between this one and the grade and the XG boost.
Okay. So in XGBoost, if you see, we have actually, this tree, and we are balancing it, like creating. Uh, Let me. How can, yeah. So we have that's the main tree, and then sub branches of this and that, and then we collect values from certain, from this, like this branch, or this branch, or this branch, and this branch. Over here we are extending our tree only, like, we have, that is the root, and we are not going to extend this one. So we are extending only one leaf, not the other one, because we are using error of that. And then you see over here we have this one, and then extending this one. So it is only ex- being extended at one side, instead of uh, extending both of the leaves, right?
Okay, I got it now. Now that helps. Okay.
Okay. Once you will, go through in the detail by yourself, probably that will make more sense. So we are not, like, at top we have certain question, yes or no. So we are leaving no, we are probing yes further. For example, I'm saying rain, and then I'm saying yes, and then if I'm saying yes, so it's heavy or slow, then we are not taking care of slow, we are going to heavy rain, and then heavy, that is actually that will helpful in reducing parameters our feature which are irrelevant. For example, I am concerned destruction due to heavy rain. So if there is no rain, I don't need to extend further why there is no rain, because if there is no rain, there wouldn't be any destruction. So we can say there is no rain, there is no destruction. So let's leave it. But if there is rain, then we'll see, yes, there is rain, heavy rain or slow rain. And if there is slow rain, then we consider like there wouldn't be much destruction, so let's leave it as it is. If there is heavy rain, then we might have to probe which areas, in which areas there is heavy rain. So then we'll go to those areas, and then in those areas the restriction is more than 80%, less than 80 is not considered, and so on. So it start probing till it reaches to its you can say actual problem. Does that make sense?
Yes, that helps. I will also go through
Uh,
that article. That probably will help.
yeah,
Thanks,
good.
Sarah. And one more, sorry to interrupt. Are these notebooks? Would you be able to share so we can have like a starter? That way we can play with it.
So yeah, I forgot that. I'll definitely share that. Basically, I'm taking these notebook from Kaggle itself, I'm not writing the code by myself because that is pretty straightforward code.
Yeah,
I
yeah,
just
that,
consider
uh-huh,
tweaking.
that's fine. But like even to have a starter, if it's publicly shareable, I guess we can search there.
Yeah, yeah, those are publicly available, and I will definitely. I'm sorry you asked me, but I totally forgot about that. I'll do it right after this session.
Okay, no problem. Thank you, Aaron. Thank you.
No problem. All right. So again, how we will apply it? We will import train and test just to uh, split our data set into train data set into train and test. You can say uh, format, like we are going to have 20% data for testing and 80% for training. So that's just a test train test, we can say, split. And then we'll have training and evaluation. So from light GBM import LGBM regressor, model is equal to LGBM regressor, as we have been doing for trees. So these lines of codes are similar one. And then we are fitting X train and Y train for model fitting, and then we are predicting our values. So these are three lines of code, sorry, four, just to import the library, call the model, fit the model, and have prediction. That's what we have been doing for every single model. Then for evaluation metrics, we discussed in last class as well. We are using root mean square error to evaluate the model. We are not evaluating the accuracy of the model. We are checking what is the error, and we have checked like the considerable values is normally lies between zero point 0.2 to zero point 0.5. And we are now uh, calling the metric mean square error and mean square error y evaluation comma y prediction, and we are not taking square root. And then printing the value, and value of mean square value is error is 42%, right? Any question up till now? So that is simple
Sorry,
implementation of
Aaron,
model.
I just
Yes.
had a question about the RMSE.
Yes.
Now, is there any range that's considered to be, I mean, it points to the fact that the model is fairly good in terms of predictions?
So practically, like there are two different things, and frankly speaking, when we work on like whatever the tutorials are, you can consider even this for rain forecasting model as well. So in those tutorials and in those data set, accuracy used to be very high, and we have less value for this mean square error. But when we come to actual practical example, so we always compromise, because uh, in every organization we don't have such high tech systems. We don't have much time. For example, considering the medical data set, we don't have time to let model to be executed on high tech machines for hours and hours. So in that case, the chances are like if this 80%, 80 to 90% is accuracy, that is considered a good accuracy for real data set. But if we are using the business models, or we are using marketing strategies, or we are having something that is very generic, then sometimes 99% accuracy or values are also not considered as good values. So this all depends upon like the problem you are facing, and how much we can compromise while considering other we can say other involved factor, in term of timing, in term of nature of the problem, in term of you can say how we like the machines we have, like high tech machines we have, and then those are reach to those the end user, because we can build a good model that is working really good on my machine but not on work well on other end, something like that. Does
Okay.
that make sense?
Yeah, it does. Thanks.
Yeah. So normally it like in real, as per my experience in real life, 80 is considered good real time algorithm, like in term of application, not only on just testing and training, uh, like in term of using at end users device. Okay, next we have hyperparameter tuning. So hyperparameter tunings are actually defining or tuning the parameters which are actually are participating to in the model to perform well. So parameters which define the model architecture are referred as a hyperparameter. This process of searching for the ideal model architecture is referred to as a hyperparameter tuning. When we define which are the parameters are involved with for the working of the model, and how we can retweak them so that performance of model could be defined better. For example, removing overfitting, removing underfitting, balance classes, and something like that. So these hyperparameter address model design questions. For example, what degree of polynomial features should I use for my linear model? Like what should be the degree of polynomial when we I am using a linear model? What should be the maximum depth allowed for my decision tree? So we can have iteration more than 35,000, but does my machines allow this or not? Right, sorry, I have just a little formatting issues. So then we have what should be maximum number of sample required at a leaf node in the CN tree. So as we have discussed for LGBM, we are actually reducing our node from 2 to 1, or maybe from 3 to 1, and something like that. So we need to define that, and initial stages we don't know. For example, even you can see this for this data set, first of all, there is lack of uh, subject knowledge. Like we most of us are not you know well familiar with geography, and we don't know like what are the circumstances that can help us. And second thing is that data is very huge with lot of missing value, and data is noisy, so we don't know how many decision tree will work over here and how many samples should be there. So we need to uh, go with trial and run. There is no specific guideline for us, like like you know these three can perform better, or these iteration or these sample could be good for a good accuracy or for good results. How many trees should I include in the random forest? How many neurons should I have in neural network when we do a deep learning? How many layers should I have in the neural network when again we are working on deep learning? What should I set my learning rate for the gradient descent? So we normally we have different type of hyperparameter tuning. Over here we are using randomized search CV. So I again have another article on hyperparameter tuning as well. Yes, this one. I have another one. Let me check if I can. Yeah, this one. That is also amazing. So normally how we normally have hyperparameters are not a model parameters, so that should be clear, like these are the parameters we have just discussed over here, like these one. And they cannot directly train from the model parameters are learned during the training. When we optimize a loss function using something like gradient descent, the process for learning parameter values is as shown. So if you have gone through deep learning, you must know the learning set is actually created, that is our my trained data set along with m into n features inside my data set, and that is the test data set from value from 1 to m, right? So I have n features and my values start from x. So m are the number of values, so m into m are actually the total feature I can have within one data set, and these are the test value we are going to check that. Learning function is actually generated from this data set, right? So we have theta feature starting from 0 to features moving towards n, right? And if we have certain values, I'll share that article with you as well so that you can go through details. So, whereas the model parameters specify how to transform the input into the desired output, the hyperparameter define how our model is actually structured. Unfortunately, there is no way to calculate why should I update my hyperparameter to reduce the loss. As I have just told you, there is no standard way to actually work with these parameters. So these are trial and run situation where we go through the model and then test if it is working fine or not, and then we pick up certain values where everything is considerable. So normally the process of model building used to be, we define a model, define the range of possible values for our hyperparameters, then define a method for sampling hyperparameter value, define evaluation criteria to judge the model, and then we apply a cross validation. So model validation, before we discuss the various tuning methods, there are purpose of splitting the data into training and test and validation. So now if you see in standard processes, when we don't apply hyperparameter, we used to have 80 to 20, like 80% data is for training and 20 is for testing. The ultimate goal for but when we include validation method, then we actually split our trained data set again into another you know section that is called validations. So ultimate goal for machine learning model is to learn from example in such a manner that model is capable to generalize the learning to the new instances. For example, over here we are saying let's suppose we have 100% data, 20% is already split for the testing purposes. Now we have 80% data for training. Now we are splitting 80 into further like 60 uh, and 60% is for actual training and 20% is validation. So validation is not part of testing. Validation is testing whether whatever our model is showing, is it accurate or not, and if it is not accurate, then we have to work on changing different parameters of our model so that we would able to validate whatever the accuracy is it 100% accurate, or whatever we are saying, is it actually whatever we are saying, or it's just like the number to calculate. So it's just for validation. So at very basic level, you should train on subset of your total data set, holding out remaining data for evaluation to gauge the model's ability to generalize. In other words, how well will my model do on data which it has not directly learned during the training, right? So somehow it's form of testing, but we are using it before actually running a test data set on it. So we have training data set, we have testing data set, and then we have training data set, validation data set, and testing data set. That's how this works. And hyperparameter tuning used to be a grid search, random search. A grid search is normally, you see, we uniformly split the data set over the different grids and then apply uh, hyperparameter tuning over this data set. But since we are already creating a grid, so there could be chances of one grid have a noisy data set, or over sampling, overfitting problem can occur over here. But random search is randomly distributing the data set and then apply those methods so that we can make sure there is no overfitting, there is no biasness over here. So you can read more detail in the article. I'll share that with you. Now we are going to actually apply that. So we have called random search CV. It's not a grid search. And then we have that is again a random let's forget it for a moment. Then we have certain parameters. For example, we are dividing our parameters 20 to 200. Learning rate is over here. We have a 3 sets. Then number of leaves should be 10 and 100, 10 root and 100 leaves. And that depth should be 5 different levels with 50 subnodes. We have again model application over here, that is a light LGBM, and over here we are defining certain parameters. For example, we have number of iterations, scoring, number of jobs, CVs, that one. Refit, there should be a refit. Random state is 42 or whatever you say, verbose is on, and then we are fitting this on X and Y. So fitting this these whole values, it is just like cat boost. And then we are printing the best parameters from that. So fitting for 5 fold, like we have 5 different iteration for each 50 candidates. So if you see, we have defined over here 50 trees, depth is 50, total 250 fits. And it's so it shows us overall all result of this whole you can say the process. So what we have done over here is that we have applied random MyCV search on LGBM. And over here is our model's final estimator. And then we are applying the best learning rate because we have already figured this out. The best learning rate is 0.01. Maximum depth should be 36, not more than that, because if we are adding maximum depth 50, so when the model is working fine at 36, why we are adding more and more trees over here? number of estimators are 25 and number of leaves should be 8. So we have figured out this from this hypertuning result, so we can apply this to our final models, right? Next we have sharp, that is explainable AI. We will do that maybe in next session, but I would like to share that article with you. That is interesting one, you can read it at your own. Okay. Yes, so that's it from these two deep learning models. If you want to discuss anything else, you can ask your question. All right. So if we don't have any question, I again would like to know: have we started, creating teams on Kaggle? Are if you have started exploring data set, or how is your EDA or model application is working? If not, I guess Miss Sumera is here, or she sh- she can help us out in formulating teams. If you are interested, or if you need any help, we can let me again. Yes, Dr. Tanvi.
Yes, Ram. Yes, Miss Ram. Hello.
Hello. Yes, I can hear you. So I'm just looking forward, like we will send you an email with the form. If you want to create a teams, you can do that. Otherwise, I guess you can let us know. We can randomly uh, make a team so that you would able to work independently with the teams within your dedicated teams. And if you come across any problem, you can always reach us.
Okay.
Reach out.
Okay. Sure.
Hello, Aram. Um,
Yes.
I'm just curious, where do you keep all the recordings? Whether I could go back and look at the old one.
So we are, I guess, uploading. Miss Sumera or Dr. Tanzila can answer this question, but I think we are uploading them on YouTube. I guess I can check with them actually.
Oh, okay.
Yes, Ms. Ram, first, thank you so much for this insightful session. And yes, for sure, we will upload maximum by tomorrow. All these, the previous two sessions and today's session in our YouTube channel, and we will share the link with all of the attendees.
Okay, thank you.
Welcome. Yes, Ms. M, that's a great approach. I think so. We should create a form and then we will share the link with all the attendees if they are interested to form the teams or they want to join the teams. Otherwise, I think in the coming a couple of days, we have to decide like at least 3 to 4 teams which we can form internally. And definitely we would like to invite the external members as well.
Hello. I have just one question, that this is my first class, but I think this is the second class for everyone. So could you kindly brief me about the program a little bit, and or is there somewhere I can go and see the content and everything? Thank you.
Hello, Siram, are you here?
Yes, I'm here.
Yeah, I think Misbah has a question.
Yes, Mispa, actually that's our third
I can say fourth.
session. No, it's not
No,
that
it's the
third.
third workshop, and the first one we had the introductory session, which was also all about the whole process.
Exactly.
Yeah.
So I can find every the classes that I missed on the YouTube then.
Yes, yes, for sure. And we will share the link soon, like
Thank you.
maximum by
Thank you.
tomorrow. Yeah. And if you are interested to join the teams in the PSU MISBA, you can contact Miss Iram or Miss Sumera.
Okay. Thank you.
All right. So if anyone else, if you have any question,
Yeah, please, if you have any question, any comments, any feedback, please let us know. Otherwise, I think we have to conclude this session, and then we will meet in the next session.
exactly.
Thank you.
Welcome.
Bye bye.
Bye-bye. Have a nice day. I think, Miss Aram, they have no questions. So thank you so much, and see you, inshallah, in the next session.
Sure. Take care.
Okay. Bye
Have a
bye.
nice day. Bye-bye.
Thank you.